Hello everyone, welcome to PUC Physics Explained channel. In this session, the third session of the PUC First Year Physics of Chapter 1, Units and Measurements, that is, the continuation of the significant figures. In this one, I am going to take by the arithmetic operations, what the result we are going to get, and for that result, how many significant figures are to be considered. The arithmetic operations like multiplication, division, addition and subtraction, and after the result what we are going to get, and that in that results how many significant figures are to be taken and what are the rules for considering the significant figures in the arithmetic operations. I'll take here. And also, if the insignificant figures are present in the result of the operation, then how those are to be rounded off to the significant figures to have the precise value of the measurement. That I am going to discuss in this session. Kindly subscribe PUC Physics Explained channel. If you are already subscribed, kindly share and comment. The first one, 1.3.1 rules for arithmetic operations with significant figures. The result of calculation, that is arithmetic operation calculation, involving approximate measured values of quantities. From that calculation, we are going to have the approximate measured values of quantities we are going to get from the calculation, and these values a, with a limited number of significant figures. The values are having the limited number of the significant figures and must reflect, those should be will reflect the uncertainties, that is the errors we are going to have from its calculation in the original measured values. The original measured values what there, from that after the certain operations, the what the result we are going to have the some uncertainties or the errors. Okay, that errors of the measurement we are going to discuss in the next session. But here we'll take the what are the rules are there to consider the insignificant figures. It cannot be more accurate. The result cannot be more accurate than the original measured values themselves, and on which the result is based. In general, the final result should not have more significant figures than the original data from which those were obtained. Okay, here in general, what we can say, that is the final result from the any of the arithmetic operation what we are going to use, that should not have more significant figures than the original data from which that result was obtained. The example we'll take before taking the rules. If mass of an object is measured to be say 4.237 gram, that is 4 significant figure. The mass of an object is measured as this value, and that value is having the 4 significant figures, and its volume is measured to be 2.51 centimeter cube. The volume of that object is 2.51 centimeter cube, which has the 3 significant figures. Then its density rho equal to mass per volume. By mere arithmetic division, what we can have, that is 4.237 gram by 2.51 centimeter cube. Then the result what we'll get, that is the result is this one, that is a 1.68804780876. Too many significant figures, that is this value is in terms of the gram per centimeter cube, up to 11 decimal places that result we will have. Then what to do about it? Then here it would be absurd and irrelevant. The result what we got, absurd and irrelevant to record the calculated value of density. This result is absurd and irrelevant to record the calculated value of the density. to such a precision, that is having the much precision, when the measurements on which the value is based have much less precision. Okay, this value what are there? The measurement of the values, that is a mass and volume, those are much less precision. Okay, it is observed to have the such more precision than that. Okay, then what to do here? Then the following rules for arithmetic operations with significant figures ensure that the final result of the calculation shown with the precision that is consistent with the precision of the input measured values. Okay, that whatever the precision of the final result of the value is there, that should be inconsistent with the input measured values. The input for the calculation, the measured values what we have used, inconsistent with that, the precision the final result should have. Okay, by keeping with that in mind, okay, the rules are set. In that first one, in division or multiplication, the final result should retain as many significant figures as are there in original numbers. Okay, as many significant figures as there in original number with least significant figures. The original number what it is there, which is having the least significant figure, that much significant figures the result should have. Okay, for example, we'll take here. Thus, in the example above, the density should be reported to three significant figures. Okay, because here how the three significant figures will take here, the density rho is given by 4.237 by 2.51 centimeter cube. Here the this number this number is having the less significant figures, three significant figures, and this is having the four significant figures. And as per the rules, the which number in the operation having the least significant figure, that much number only the significant figures the result should have. Therefore, this will be 1.68804 something. The density what we have calculated, that is rounded to a 1.69 gram per centimeter cube only. This is the rounding off in the division of the division operation for considering the significant figures. Now we'll take the another example. Similarly, if the speed of light is 3.00 into 10 raised to 8 meter per second, the speed of the light, that is also rounded value, and it is having the three significant figures. And 1 year, that is a 1 year equal to 365.25 days, and has the 3.1557 into 10 raised to 7 seconds. Five significant figures it have, and this is having the three significant figures, the speed of the light and the uh, time for the 1 year what it is there in terms of the second, it is having the five significant figures. Then light year, the light year can be calculated as the length of travel of the light for the one whole year. For the one whole year, what is the length of travel of the light is there, then that can be calculated by multiplying the speed of the light with the time available for the 1 year. Okay, therefore 3.00 into 10 raised to 8 meter per second multiplied with the 3.1557 into 10 raised to 7 second, that will give the 9.46041 into 10 raised to 15, and here the some numbers are more. And here, as per the rules of the multiplication and division, the one of the original number which is having the least significant figures, that much we need to take in the result. Therefore, in these two numbers, this first number is having the three significant figures, and second one is a five significant figures. And we should take the least significant number, that is 3 only. Therefore, it is rounded off to 9.46 into 10 raised to 15 meter, three significant figures. This is for the multiplication example. Then further moving in addition or subtraction, the rules is that the final result should retain as many decimal places as there are in the number with least decimal places. Okay, here the rules is that not concerned to the significant figures. It is concerned to the decimal places. Okay, the number which is having the least decimal place, that much decimal places only the result should have. And considering the result, the remaining the significant figures with the least decimal place, how many will have, that much we have to keep. Example will take the sum of the numbers. Three numbers will take here: 436.32 gram, 227.2 gram, and 0.301 gram. By mere addition, we are going to get the 663.821 gram is the result. Now we'll take the how many decimal places each number is having. The first number is having the 3 and 2, two decimal places. And second number is having the point 0.2, only one decimal places. And third number is having the 301, three decimal places. And here, but the result we got the 663.821. But as per the rules, we should take the decimal place in the result in which number is having the least decimal place of the original value. Okay, that is the this second number is having the least decimal place 1 only, then this number we should result in that one only decimal place we should take. The least precise measurement is 227.2 gram is correct to only one decimal place. Then the final result should be therefore be rounded off to 663.8, only one decimal place we'll consider. Then for the similarly, the difference in length can be obtained as, that is for the subtraction. Here point 0.307 meter minus of 0.304 meter is result is 0.003 meter. Here the first number is having the three decimal places and second number is also having the three decimal places. The result we got here the three decimal places. Then this can be expressed in the scientific expression, that is the power of the tens, like that if you express 3 into 10 raised to minus 3 only, the result we can get. But the here we should have the three decimal places as per the rules. 3.00 into 10 raised to minus 3, we can write this one, so that that is rounded to the three decimal places, the result what we got. Then here one note we have to take: in the addition and subtraction we should not use the rule of the multiplication and division, and in the multiplication and division we cannot use the rules of the addition and subtraction. Okay, that just one discussion we'll have. Note that we should not use rule 1 applicable for multiplication and division and write the 664 gram as the result in the example of addition. Okay, here 664 rounding off this one, 664 we cannot take here, and 3.00 into 10 raised to minus 3 in the example of subtraction. Okay, that is here in this also 3, as these two numbers are having the three significant figures, we can keep the three significant figures. As for that, we should not do this. Okay, this is we cannot round it off like this. Okay, because what is the reason there? They do not convey the precision of measurement properly. If you use the rules interchange, that the precision of measurement they cannot convey. For addition and subtraction, the rule is in terms of the decimal places. The rule is in terms of the decimal places. Okay, this is for only the just discussion. Then next we'll move for that, the rounding of the uncertain digits. if the uncertain digits are there in the result of the operation and how those are rounded off. And that discussion will carry out here. The result of computation with approximate numbers which contain more than one uncertain digit. If it is contains the more than one uncertain digit, then that should be rounded off. That should be rounded off. Then the rules for rounding off the numbers to the appropriate significant figures are obvious and most cases in most cases. Okay, that rounding off of that significant numbers by taking the uncertain digit, okay, that is obvious in the most of the cases. And how the rounding off can be taken, okay, the one example we'll take here. From that the rules we'll discuss. A number 2.746 rounded off to the three significant figures is 2.75, and the number 1.743 rounded off to the 1.743 rounded off to the 1.74 only. Then how that comes? How the rounding off is taken? What is the rules? Here we'll discuss the rules. The rule by convention is that the rule is by convention is that preceding digit preceding digit to the insignificant figure is raised by 1 if the insignificant digit to be dropped is more than 5. Here in this first case, what it will take? Here the 2.746. This is the insignificant digit. And if this insignificant digit is to be dropped, it is more than 5. Okay, that is dropped, and the previous digit is raised by 1. The 1 it should be added to that. 1 is added. And that is rounded up to the 2.75, the result we got. Okay, that is by the rule. And if and is left unchanged if the digit is less than 5. Okay, here this digit, the insignificant digit is less than 5, and the previous digit what it is there, it is left unchanged, and therefore it is rounded up to the 1.74, and that is the rules for the rounding off of the this result by considering the insignificant figure which is more than 5 or less than 5. Okay, that is the this is given in the above example. Then next one, but if the number is 2.745, the insignificant figure what is there, it is not less than 5 or more than 5. If it is exactly 5, in which the insignificant 5 digit is 5, then what to do? For that there is a one rules that we'll discuss here. Here the convention is that if the preceding digit is even, the insignificant digit is simply dropped. Simply dropped. If the preceding digit is even, the insignificant figure what it is there, it is simply dropped. The previous digit will not be unchanged. Okay, that insignificant figure or digit is simply dropped. And if it is odd, the preceding digit is raised by 1. Okay, by 1 we have to, if this previous digit is odd, then preceding digit is raised by 1. Then for that we'll take the example here, that what the rounding or the raising or changing we are going to take. The discussion will continue. The number 2.745 rounded off to the three significant figures, that is 2.74. How it is? Okay, this preceding digit is even, therefore that insignificant digit simply drop without changing any preceding number. On other hand, if the number is 2.735, this is the odd, preceding digit is odd, then the insignificant figure is dropped by adding one number to the this preceding digit. Is rounded up to the three significant figures becomes 2.74 since the preceding digit is odd. Okay, if the exactly 5, the insignificant figure, okay, that is even, number is even, that is it will be unchanged, insignificant figure is dropped. If the number is odd, okay, that is raised by 1 and the insignificant figure is dropped. Okay, that is by the convention. In any involved or more complex multi-step calculation, if the number of steps are involved in the calculation, that is involved in a complex multi-step calculation, if it is there, in each step, the result we are going to get, and that result should be rounded up to the some significant figures. Then what to do there? In intermediate steps, you should retain one digit more than the significant digits. Okay, as per the rules, how many significant digits or figures we need to keep in the each calculation? But there we have to keep the one more significant figures. Okay, that is, and later rounded off to the proper significant figure at the end of the calculation. Okay, at the end of the calculation, there is proper significant figures what are present in the all the that uh, measured values we are used for the calculation. Okay, those are to be considered at the end, and in the intermediate steps, one more digit is to be taken into calculation, and that is kept. The some other rounding calculation consideration will take here. Similarly, a number known to be with many significant figures, such as in 2.9979245 into 10 raised to 8 meter per second for the speed of the light in vacuum, is rounded up to the approximate value 3 into 10 raised to 8 meter per second, which is often employed in computation. Most of the computations we are going to use 3 into 10 raised to 8 meter per second only speed of the light, which already earlier we have used for the calculation of the light year. Like that, this is the one, the rounding off also we are going to use. Then finally, remember that exact numbers that appear in formulae like 2 pi in t is equal to 2 pi and under root of L by G have a large infinite number of significant figures. And what are those? The value in that equation is pi is equal to 3.1415926 so on, is known to a large number of significant figures. That pi is having the large significant figures. And you may take the value 3.142 or 3.14 for pi with limited number of significant figures as required in the specific cases. How this in the specific cases 3.142 we can take, and the 3.4 in the specific cases of the calculation we can use if the large number of significant figures are there in some values. And this is about the rounding off of the insignificant figures to the proper values, which will give the calculation, the consistent calculation, and the result will be have the consistency with the original measured values. This is about the third session of the first chapter, units and measurement. The remaining parts I am going to take in the further sessions. Thanks for watching. If you like, share, subscribe, and comment.